Hi all, this research work discusses the problem of microservice identification from monolithic application and is the result of a joint collaboration between three research teams in Lyon, Dubai, and Marrakesh. The following outline will be adopted. At first, the context of our work, along with the challenge to be addressed, will be introduced. Then, an overview of the proposed approach in terms of dependency models and clustering algorithms will be presented. Before concluding, experiments will be discussed. A monolithic system means one block of strongly coupled components, raising a lot of concerns like not easy to maintain, not easy to accommodate user changing needs, and not easy to adapt to new ICT solutions. That's why many organizations have decided to migrate from monolithic systems to microservices-based systems that are in fact a set of loosely coupled components. One challenge in this migration process is how microservices can be automatically identified. The existing solutions are often based on the use of log files, UML specification, and code analysis, for instance. There are a few solutions that identify microservices from business processes. Our contributions are manifold. First, a BP-based approach for the automatic identification based on dependency models that would feature dependencies between BP's activities from different perspectives. Another contribution is a collaborating clustering algorithm to group activities together in a cohesive way. Each group is likely to form a microservice. This way of doing enables to keep data generating from each dependency model separate and then gather clustering results so that microservices are identified. As shown in this figure, our approach takes a set of BP specification as input in order to first extract different activities dependencies and then capture them into dependencies models. We define three dependencies models: control, data, and semantic. The first represents a control dependencies between two activities. The second gathers data dependencies between two activities through their shared data in terms of read, write, and create operations. Last but not least, the third represents the implicit semantic dependency that could exist between activities named. Each data generating from one model is stored as a square dependency matrix that would serve as input for the clustering algorithm. Here we have an example of BP for biking, including activities such as get a bike after checking user credentials. Given a BP specification, we use the models to generate different dependency matrices. Since activities could be linked via different operators like sequence or and XOR, we formalize the control dependencies based on the occurrence probabilities of the activities. For the control dependency model, we can have either a direct link or an indirect link between two activities. The following formula shows how to compute control dependencies between two activities as per the operators that connect them. For data dependency model, the idea is that activities that exchange mandatory or critical data and share a lot of data should be part of the same microservice. Here we have an example of matrix that store control and data dependencies. All generating data could be merged and used by an existing clustering algorithm to group similar activities. We consider that this integration won't include any data, so data belongs to different models. Then we keep each matrix independent and then we propose a collaborative clustering algorithm, CAC, that extends an existing one, namely classical hierarchical agglomerative algorithm. Our algorithm is then jointly performed by A nodes. This number of nodes depends on the number of models used along with the number of BPs. Thus, Each node will be in charge of one and only one dependency matrix. Each node will generate its clustering result by using its own matrix, but by keeping an eye on what other nodes are performing. To allow this collaboration, nodes share a score matrix which is updated by all nodes at each iteration. At the level of each node, the pair of clusters to merge are computed, not only by using the local matrix, but also by using the shared one as per the following formula. We implemented our collaborative clustering and tested it by using our generated matrices. For each model, we measure its done index along with time index. This test shown that the control dependency model is more informative than data dependency model. This also shows that the quality of the clustering result obtained from the control dependency model is better than the one obtained if we merge both control and data dependencies model. This confirms that aggregating different dependency matrices degrades the quality of the final microservice generation. Right now, we are working on the definition of new models to capture more dependency types between activities. For instance, we think that the user feedback expressed in natural language in conjunction of the use of NLP techniques could improve our microservices identification approach. Thank you for your listening and watching.